Okay, guys, we're going to go over a couple problems here, preparation for tomorrow's class. A little recap recap of some algebra stuff called systems of equations. So we look at this first problem. So you solve the systems of equations, and what we're looking at, we're trying to basically find where is the point of intersection between these two lines. So here's a line y equals x minus 4, and here's a line y equals 3x plus 2. I'm going to look at them on Sketchpad right here. Here they are, okay? Here's 3x plus 2, and here's x minus 4, okay? And what we're looking for is to find where they meet. And Sketchpad tells us that they meet at -3, -7. So we want to find out how we can do the algebra to find out the same thing, okay? So we go back. We're saying we're going to use what's called a substitution method here for this one because it's what works easiest on this. So in other words here, since y is equal to x minus 4 and y is also equal to 3x plus 2, I can set them equal. That is, I can say 3x plus 2 is equal to x minus 4. And now I can solve. I can subtract x. That gives me 2x, 2x plus 2. Okay, 2x plus 2 equals -4. And now I can subtract 2, and that gives me 2x equals -6, which says x equals -3. Well, I know what x is. Now I want to know what y is. So I could go back to either one of these because either one of these says give me x and I'll give you y. Okay, so here we go. All right, when I give it the x value of 3 into the first equation, I have y is equal to -3 minus 4, which is -7. Okay, so I know that now the point where they meet is -3, -7. Okay, let's go over here. Now this one's asking for the same thing, but it's a little different. Okay, now how is it different? Well, it's different because it's not written exactly as y equals something. Okay, but I could make that. I could easily arrange for that to happen. Then I could do a substitution. So let's do it this way. Let's look at this first equation. Okay, if I do one thing here, if I take 2x minus y equals 8. Now, if I exchange where y is and where 8 is, I get 2x minus 8 is equal to y. Now that will allow me to do that substitution into the second equation. So I rewrote the first equation. I'm going to substitute it into the second equation. Okay, so what's going to happen? Now I'm going to go to the second equation, which reads x plus. Now I have 2y, but I know that y is equal to 2x minus 8. So I go x plus 2 times 2x minus 8 is equal to 9. I'll do my distributing. X plus 4x minus 16. Don't forget to distribute over both of these terms is equal to 9. Now I tie my terms together. I get 5x minus 16 is equal to 9. Okay? Now, what do I want to do? 5x, right? I want to add 16 to both sides. Add 16. That gives me 5x equals 25. 5x equals 25 divided by 5. I have what x is. X is equal to 5. Now I want to know what y is. Well, remember up here, it says y is equal to 2x minus 8. So y is equal to 2x minus 8. But I know what x is. So y is equal to 2 times 5, that's the x value I found, minus 8. So that's going to be y is equal to 10 minus 8, which is 2. So I find that these 2 points intersect at the point 5, comma 2. Okay, let's do a couple more. All right. Now here's one. This is going to be a little peculiar. Okay, we're going to come back to that in a moment. Um, let me do number 3 here first. Okay. Now number 3, okay, is there's a nice easy way to do this because you notice this is x and x are the same coefficients. Y and y are opposite coefficients. So this is the addition method. By the addition method, I mean I can add column for column. Add x and x, that's 2x. Add y and y, that's negative y and positive y, that's 0, okay? So, and then adding 2 and 1 equals 3. So it tells me x is equal to 3/2, all right? Now I know x is equal to 3/2. I want to know what y is equal to. So I can go back to either one of these equations, okay? And I can say, well, let's see, go to the second equation. X plus y is equal to 1. I know what x is. X is 3/2. 3/2 plus y equals 1. So y is equal to 1 minus 3/2. 1 minus 3/2 is 1 minus 1.5, okay? Which is going to be y equaling negative 1/2. So I found my point of intersection is, okay, is x equaling 3/2 and y equaling negative 1/2, right? Now, I'd like to try that here, but if I try it, nothing drops out. See, the reason why when I added column for column over here was because I had opposite values of y. I don't have opposite values of y here, okay? I don't have opposite values of y. But I can force that to happen by taking the top equation and multiplying everybody by 2. Because if I multiply everybody by 2, look what happens, okay? I get a 6x plus 2y equals 8. And again, it's an equation. As long as I do what I do to one side to the other, it's fine. So I multiply both sides by 2. Now I take my bottom equation. I don't have to adjust that. And now, nice, what happens is, okay, I've got 2y and a negative 2y. They'll disappear. But then so will the x's. So basically here I have 0x minus 0y is equal to 12. Well, what happens in that case is that the two lines are basically parallel. That means parallel lines means they do not intersect. And if they do not intersect, there's no point of intersection. Now, if you wanted to, you could check and you could see that the slope on each of these lines were the same, okay? And if you check the slope that was the same, then of course the lines are not going to be parallel. They're not going to meet. Okay, let's look at a couple more here. All right. Now, this one looks like we have to simplify this first equation. So if I simplify that, I get 2x, okay, let's bring the y to the other side. This is what I'm going to do. I'm going to bring this y over here. I'll bring that 3 over here. So I get 2x minus y, okay, is going to equal to 6. You should be able to see that. Just collect the x's and y's to one side, and you know, the numbers to the other side. Now, the second equation, 2x plus y equals negative 3, will invite me to do that adding column for column. That's called the elimination method. Adding column for column gives me 4x here. Okay. Adding column for column gives me 4x. Over here, adding column for column here is going to give me a 9, or rather, I'm sorry, you can see when I add the y's, they disappear, okay? When I add the y's, they disappear. And in that happening, what's going to happen is that x is going to equal, I could solve for x, that's going to be 3. So 4x equals 3 now, okay? And with 4x equaling 3, I get x is equal to 3/4. Now, if I take that 3/4 value for x and I throw it back into my equation, I can solve for y, okay? So we'll do that. We'll go back to that second equation. where it says 2x, well, that's 2 times 3/4 now, plus y equals -3. Okay, so that's 6/4 plus y equals -3. Now 6/4 is 3/2, okay, minus 3/2, that was positive 3/2, excuse me, and plus y is equal to -3. So y is going to be equal to -3 minus 3/2, which is, that's -3 minus 1/2. Y is equal to -4 1/2. So that's what I got for my x and y. X comma, the x is 3/4 and y is -4 1/2. Okay. And the last one I'm going to leave for you, but this is going to be an interesting one. In fact, let me just work on this. Let me just show you something. So this is y equals x plus 1. This is a little tricky. So what I'm going to what I want to redo is I want to rewrite the bottom one to look like that. So if I have the top one is y is equal to x plus 1, and now if I take the bottom one and I rearrange this, I say, okay, let this say, bring a y over here, negative y equals negative x plus 1. Or if you wanted to, here's probably a better way of looking at it. Add 1 to both sides, and you got x plus 1 equals y. Or you got y equals x plus 1. So by simply changing the second equation, it is identical to the first equation. So if I'm asking where do these two meet, well, they're not going to meet anywhere, okay? They're not going to meet anywhere because they're both the same line. So they are the same line, and therefore there's not going to be any point of intersection. So remember, these problems that we're doing, we're trying to find where the lines meet, okay? So if they meet at a point, okay? And if they do meet at a point, we should be able to find that point where they meet, either by, okay, setting them equal to each other, as we did here. This was easiest to set equal to each other, okay? Or doing a substitution, as we did here, okay, where we solved one of these equations for y and plugged it into the second equation, or by doing an elimination method that we did in this problem and over here, just adding up the x's and the y's, which will easily eliminate if the coefficients of one of the variables are opposite. If the coefficients aren't opposite, then we can make them opposite by, okay, multiplying by some number, okay? So you have, okay, the one method of setting each equal to the other, you have the substitution method, or you have the elimination method. And sometimes the lines do not meet because they're parallel, which was the case here. And sometimes they do not meet because they're exactly the same line. Okay, and if they do meet, we want to know where they meet. And that's it. We'll have some of those exercises tomorrow.